Welcome, everyone. Thanks so much for coming on for the second time. And I also wanted to share a little bit more of an update of the huge push towards LiveStore point 3. And yeah, maybe starting with that, this has been in the works really for, at this point, I think over a quarter. So it's been not the regular release. So this has been in the works since end of November and has been already the foundation for like really big changes and improvements in LiveStore. And I'm really excited how that's coming together. I've teased some of that already during the last office hours, but I'm really excited how that's coming along and getting a lot more stable, a lot faster, etc. And I've also, since the last time we did the office hours, I've already released a couple of dev versions, which I think some of you have already given a try. But I'm excited to share a little bit more what's been included in this. The two main parts are really like the new sync system and the new node adapter. And those two things in combination really unlock a whole bunch of new use cases, particularly given that you can now also run LiveStore applications on servers and build all sorts of different apps. Also very happy to discuss more. So before I show a bit more of the new sync system and the node adapter, I also have been working on a couple of other improvements. We got a really exciting contribution by this person. They have added initial support for Solid. So really great PR, which I indirectly merged. I had to, given that the point 3 branch was already changed so many things, I helped a little bit and manually integrated those changes. But now there's like a first version of a Solid package. So for those folks who are curious to try out Solid, it's been actually really cool because the involved code for this was pretty little. And I think that just speaks to how amazing Solid is. And I think it's quite a step up from React in terms of simplicity, performance, etc. I was really excited about how simple and how performant it was. And just to show you, the actual integration of the code for Solid is not even 200 lines of code. And the actual implementation that I ported over, I think, is even fewer lines of code. And so really excited about that. There's still some work necessary here to just, I would like to see some more tests. In fact, we already have a deployed example of that. I think over here, we have here to do MVC Solid. And if we're now looking at that, open branch deploy, we have, this is my dark reader. Let's invert this. So this is the full Solid app and works just like a React app. And yeah, I'm reloading the page, but it's like you can't even like see the reload because it's rendering so quickly. So really excited about that. And huge thank you to the contributor who made that possible, since I wasn't too familiar with Solid before, but I think it's a really good fit. Another, I think, really noticeable change is that while facing another limitation, I had to somehow solve that limitation. And one of those happy coincidences happened where to address it, I had to simplify things further. And that allowed me to remove one of the pieces in LiveStore that I've always felt like semi-happy about, which is this used scoped query, which is basically if you create a query within, let's say, a React component, and that depends on other things, and you will basically create a query, and then you need to make sure that you don't leak it and it gets disposed again properly. I've now changed the way how queries work. You don't need the use scoped query anymore. You can just use query for everything. That's a huge simplification. You still need to make sure that if you rely on anything in here that is not coming from LiveStore, since LiveStore has its own signal system. So for example, here, let's say you have an issue ID that is available somewhere in React state, or you could still need to help LiveStore account for that, to lift up something like that into a LiveStore signal, and then it would be tracked automatically. But yeah, overall just streamlined a lot of the APIs. And before you could run queries directly with .run, but that was always like a little bit shaky because they were implicitly bound to a store, and now you need to execute them with a store explicitly. And one thing that also allows now is that you can have a LiveStore app where you have multiple LiveStore instances at the same time. A few users have been like now running into this where different parts of a app, let's say like one of my favorite examples is always TLDraw, where each TLDraw document might be its own LiveStore, for example. So when I sign in here now, I get an overview of all my other TLDraw documents. And for example, that list could be in a different LiveStore instance. That is now much more easily possible, where you can have multiple stores, and then you use your different stores and run the queries against that. I want to still tune some of the hooks, some of the React hooks, to make that more straightforward. By default, a React hook uses the store out of the LiveStore provider, but you can also pass in a store explicitly as one of the arguments. So really happy how that turned out. And yeah, I've also once in a while it's useful to debug while you're working on something live. And so one thing I've also improved a little bit is that you can now always have access to the LiveStore instances here by default. So here you can see there's like multiple ones. And if you're only using one, you can get access to it with this underscore thing. And here, this gives you access to the LiveStore instance dev namespace. And in that dev namespace, there's a bunch of useful things. So for example, from here, where we currently see this is the database, we can from here, for example, download the database. And the same thing is obviously also possible from the DevTools, but sometimes while you're debugging, this can be useful to do it right from here. And yeah, that's not possible. You've also seen some of those other things. So for example, if you want to shut down the app, you can do that. You can hard reset it. Here in this global variable, you have access to the running LiveStore instance or instances if it's multiple ones. And you can do nifty things like this from here, like downloading the database, which I've already done. Oops. Let's see. Yeah, you have access to a bunch of different things here, including seeing the LiveStore version. And one thing that's also really nice about this is that you can from here also see the sync states. And yeah, with that, which state for example here, the leader, since in LiveStore you have a tab and then there's a leader thread, which actually is responsible for persistence and so on. Another thing that is really cool is the LiveStore DevTools have been also seeing some improvements. So one thing that's been bothering me quite a bit is that as you've been working on on your actual app, like on the schema, etc., that causes your own app to live reload. But given the DevTools also depend on the schema, it causes the LiveStore DevTools to reload. And if you think about it, there's actually like almost a client-server relationship happening between your app and the DevTools. And sometimes they ended up getting in weird states and it was disconnected. For example, like if you reload your app, now this needs to reconnect to here, or if you reload this one, this needs to reconnect to here. And there were some instabilities, and that's always bothered me because those tools should be there to help you. And if those tools don't work, that interrupts your flow state. And that's really something I wanted to fix. This has been taking me a lot of work, and I had to innovate in ways that I didn't intend to. But yeah, if you're familiar with something like Console from HashiCorp, so I basically had to build something like this, but for a web context, for different browser tabs and so on, to make this work seamlessly. The benefit for you is like stability. Another cool thing here that's changed in the DevTools is that you see the sync state here now automatically, or like an indication of the syncs. So those are the sync heads. Think about the sync heads similarly to like when you're in Git and you have like error. Let's take an example. So those are Git hashes, and they're always like showing basically, hey, this is like the head of where a Git repo is currently pointing at. And in LiveStore, there's like a continuous event version, and whenever we change something, this advances. So if we can also see it here in the mutation log, when we do something, there's a new event. And also when we change this, notice those are like it's the first the global event ID, and then there's the local mutation ID. And given that this is this layered system where there's the tab, then there's the leader worker, and there's the sync backend, this is what you now see here in which states the various things are. So you see it basically, if things go wrong, then you have like more visibility into what is going on. And typically there shouldn't be anything problematic in that regard, but you can, for example, if you don't have network connectivity, and let's see if we're now saying we're offline and we change some of this, notice the client session here and the leader are already up to date, but the sync backend isn't. And so if we go online again, now the sync backend has caught up. And this is, so if I'm opening the same thing here in Arc, in an incognito tab, then this will have caught up to the same state. And having access to all of this, what's going on in the DevTools, is just based on my own usage, has always proven like very useful, and I'm quite happy about that. And I'm planning to invest further into just providing visibility into all things related to syncing. Yeah, the DevTools should just get a lot more stable and a lot snappier. One other thing that I've been including here, which I think I haven't mentioned yet, is that there's like now a fully fledged SQLite playground in here. So you can use it by default. This is running it starts with an empty SQLite database. So when you say from SQLite master, we don't get anything, but we can load in the app.db. And if we're now running it, we get a full database from our app. And so we can do things like select star from to-dos. And now we get our to-do state here. If you want to experiment with SQLite queries against your real data, this can be quite nifty. Export database here, etc. Those are all tools that I've just over the course of working on Overtone and other things that I needed at some point. I'm trying to improve the developer experience for myself, and by extension also for you all. Hopefully those are useful for you. A few other things. Yeah, I've worked quite a bit towards better documentation. If we're taking a look here, LiveStore dev, preview deploy, maybe this is one that shows this. Yeah, documentation still has a long way to go, but I tried to keep things here up to date and keep things in sync and just cover a little bit more how things are working. So trying to write things down more, particularly now in regards to syncing. And whenever people are asking questions in Discord, I also see that as an opportunity to both answer the questions as well as address things here a little bit more, providing a few examples. You all are invited to ask questions, and I'll try to, at the same time, also improve the docs here. And since there's quite a lot that has gone into the foundations of LiveStore, but too much of that is only in my brain and needs to be shared somehow. But yeah, I'm in the process of doing so. A friend of mine has been helping me out by improving the linear light React example, since I think some of you might have taken a look at this over when you've been just checking out LiveStore as a reference. And by now we also have a really great Expo example by Bido for the linear light app for Expo. And I feel like the linear light app on Expo has looking so good that we wanted to improve the web app as well. And so I'm really excited how that's been coming along. Let me, oh yeah, by the way, there's a website coming up which I might show the next time. So let's take a look. This might be it. Yes, I think this is the one. I will actually share a link with you all here so you can check it out for yourself. And I think I need to remove the double dark mode. So this is a slightly overhauled, and this is still work in progress. There's still many things that will be even further improved. But yeah, so this is the new version of Linear Light. So you can like manually create issues, but you can also right from here say, actually give me like 50. And from here, you can go in here, obviously change anything. All of that is locally stored. You notice the reload time. This, by this point, also, I think, fully offline in a service worker. So I think if we were to disable this and reload this, yeah, so this is fully offline. I will still also hook it up with syncing that you can see LiveStore full in action here, but also with things like keyboard-driven commands. And yeah, so you have a list view. Also notice that the scroll position here is being retained as we navigate or reload the page. So just to give it a little bit more of that native app feel. But there's also the board view has been improved. Now there's like a drag and drop, which, yeah, there's still some things that we want to improve here, but really happy how that's coming along. And yeah, this will be wired up with like the various like DevTools options, etc. But from here, you can also reset the database. This is currently broken. I need to fix that part, but you see where this is going. And just to inspire a little bit folks building apps with LiveStore to have a nice and up-to-date resource. But yeah, really excited where this is going and looking forward to your feedback that we can still incorporate before this gets merged. Cool. What else? Yeah, I'm not sure how many of you are using OpenTelemetry together with LiveStore, but I'm heavily relying on anything OpenTelemetry to understand what's going on, particularly when it comes to performance, etc. So that integration keeps getting better. There were a few bug reports which I've been addressing, so thank you so much for continuously providing those bug reports. And yeah, Igor, also here in the call, has been working and is still working on some exciting performance improvements in regards to SQLite with the write-ahead log mode. I'm really excited about that, but maybe we can share more about that next time. But yeah, maybe ending on the preview side here with one last demo, which is basically the following, that you can have your app and have it be in sync with the node adapter. Let me show you. We're opening a new store here. And so this is completely fresh. And I have a little CLI that uses the node adapter. And I will just join in on that same store ID, 101. And by default, as this is starting, this returns an empty query result. I need to remove some of those verbose logs. But the same as here, it's like empty. And when I now create things here, notice the node adapter, we're basically getting real-time query results just as we get in the browser app. We're now also getting in node code. And it's like exactly the same code, like the same schema definition, the same query definition, and you can just use those in a node context. I want to improve this further, that it also works in environments like Cloudflare Workers directly. But I think this opens some really interesting opportunities. And given that this is just SQLite under the hood, we can actually, let's open this in the corresponding folder. This should be here. This, I have specified here a path for that's basically all the CLI does. Is like just this little app just takes those parameters and invokes it correctly. And here I'm pointing it to the right schema path, and here I'm pointing it where to store the data. And yeah, given this is just SQLite, I can now from here go here, and here we have our full SQLite database, where we can here take a look at the to-dos. So those are the to-dos we have over here. If we create a new one, The only thing we got to do is this already knows, but here we got to press that button. But now on our hard drive, there's a fully up-to-date SQLite database, which I think also opens the door for like many different ways how you can deal with that. And so, yeah, this is where you have like your web app and your other adapters and your web app, your Expo app, your Node apps, all can be in sync and share data and even be resilient. So if this one goes offline, you can do stuff and later come online and it syncs up. And one last thing that I'm really excited about is, let's say you're currently working in your Node app and something isn't working. You can, even from the Node LiveStore instance, you can also access the LiveStore DevTools. You can basically, this is now the Node adapter, which hosts itself a instance of the LiveStore DevTools, which we're accessing here. So this has nothing to do with this web app here. We can close the web app. Let's reload that. And we're now here connected to this Node app, and where we can do things like this, for example, toggling those states, and you see it here updating in real time. And yeah, this opens a whole bunch of like really cool opportunities. We can now see also here the live queries that are running in this Node app. And you can see the mutation log, you can see network events, slow queries, etc. Really excited how that's coming along. But yeah, I'm curious whether you have reactions or questions to this already.
Does that open up the use case where you could take multiple LiveStore instances, consume the event log, and then like populate like a Postgres database or something?
The mutation log is still the source of truth for the database. So the mutation log, this is the same as we're seeing here. You designed this as part of your app. So for this particular app, let's take a look, LiveStore mutations. So those are our mutations here. And everything that's happening in the log is basically one of those instances. And so you could either apply this also to Postgres, given that SQLite should be mostly a subset of Postgres, but you could also ignore that part of the mutations, and you basically just traverse through the mutation data and then interpret it for your Postgres database. This is certainly something that should already be possible and like in an application user land. It's just not something that I have yet systematized in some off-the-shelf way. But if you want to try that and just have like Postgres as another centralized read model, I think that should be totally possible. The basic idea is basically just that you always remember, okay, what was the last event ID that I've seen? And when you come online again, you just from here on work further, or you can always throw away your read model and start from scratch and work your way up.
Just wondering, so with the event log, let's say that there's some user that's offline for a long time and then they come back online and we get that event. I remember you talking about how we need to undo some of the events locally to get back into the correct order.
So what you're referring to is rebasing. And so the idea for rebasing is like very analogously to Git. Let's say you have one user which has sort of those events. Let's say this is Bob, and Bob has, I'm going to simplify this now and basically say Bob has event 0, 1, 2, 3, 4, 5. And they're all, I'll say 0 prime, 1 prime. Those are all prime events. And those events they basically need to still be confirmed. And by the way, this is all happening. Those are the under the hood how LiveStore works. You don't need to deal with that in your application. But so this is now how Bob's LiveStore instance works while offline. So let's say Bob has been on Mars vacation and there is no good, reliable Mars connectivity yet. Meanwhile, the sync backend has actually seeing 1, 2, all the way until like event 1000. And so now Bob comes online again, back to Earth. And what Bob basically does is like Bob talks to the sync backend and give me everything since. And in fact, here, Bob, or let's say Bob shares up until event 1, including 1. Bob still remembers from Earth before. And so Bob says, hey, give me everything since event 1. And since 1 was the last thing that he really knows, like, hey, this is what I still got from last time. So what Bob does is he like stashes those temporarily away, now pulls those down, like very similar to git pull, now has those for sure, and nothing's going to change this. And now Bob needs to basically rebase those. And very, very basic, he needs to rebase the version numbers. But let's start with this. 2 becomes this plus 1, and so on. 1002, Abend 1004. And so Bob now so this gets returned. So those were returned. And then in the next step, Bob says, okay, here are some new ones. Those are the new ones that I want to push. And now the sync server afterwards also knows those, and those are no longer prime. That's basically how it works. And a default rebase is basically everything is taken as it was before, but you could, like you are familiar with rebasing from Git, this might also be, like Git might force you to say, okay, here's like a merge conflict, please deal with it. And this is something that I also plan to support with LiveStore, that you as the app developer can define what constitutes a merge conflict. And then you either, as the app developers, say, I always know how to resolve it. It should always be Bob's been on Mars, Bob wins. Or you can apply any sort of rules that you want, or even provide it to the user, similar to how Git asks the user, aka the developer, to reconcile conflicts. You, as the app developer, could lift up the merge conflicts to the user to let the user deal with it. And then you basically just derive new events, and those then get pushed.
Okay. So then theoretically, if you had someone that was consuming the event log but read only, then they would never have to rebase?
They wouldn't, when they only have read-only access, so they never write to a mutation log. There's 2 aspects to that. They won't be able to write to the remote mutation log, to the sync backend one. That's one thing. But do you want to even build the app that locally they don't even write to their own database? You can do both. If you say locally they can do writes, but remotely they can't, then they would still need to do the rebase. They would do basically everything except this step would fail, but they still would need to rebase to get a conversion behavior on the local client.
Yeah, I think the use case that I was imagining is if you had 1,000 users and you're consuming everybody's event log, and then from a read-only node server, and that node server is just populating one shared view database on like Postgres or something. And then would you ever have to go back and recreate?
No. Ever, yeah. Awesome. The only scenario, and this actually is a nice segue to one of those other questions, which is in regards to schema migrations. The only reason why you might want to start over from scratch is if you want to change the schema for your read model. But that's the beauty of, and actually one of the reasons why I've started with LiveStore is because I've basically just been, throughout my entire development life, been traumatized by schema migrations. And I've been never happy with the various trade-offs. And I've come to the conclusions the best schema migrations are no schema migrations, where you don't need to migrate the schema. You can just recreate it. Similarly to where we went from jQuery to React, where you don't need to migrate your DOM nodes from the previous state to the new state. You can just, in your React component, like React automatically handles that. Think about it similarly for this. While, for example, if you're looking into the internals of a LiveStore app, let's go here again. And so if we're looking into this under the hood with this OPFS Explorer, then so we want to look into here. There's a pool of database files, so you can ignore that. We're just interested in those two. So one of those is the similarly to what we've had over here. So one of them is like the app, and one is the mutation log. And notice the app.db, this has this little suffix here. And the suffix is basically the hash of your schema definition. So if you were to change your schema definition, the hash would change. If we're, for example, going in here and we would, whatever, call this, or we create a new one, other, and it's nullable, and we would save that. There's still no hot module loading for Node. But if we were to rerun this should, notice this has created a new app.db. The old one is still there. I actually don't recall anymore which one was the new one, which one was the old one. But the more important part is like both are fully in sync. The only reason why I still keep it here is that I don't see a reason beyond saving this space to delete it. This might be useful for you as a developer if you do this accidentally. We're actually thinking about for the web version where you might have more limited space. We might archive out some of the unneeded databases. But the only thing that you should not delete, that you should not lose, is the mutation log. At least you shouldn't delete it if you haven't synced it yet. If you have it synced, for example, in this case, everything is synced, we can go ahead and delete that database, that entire folder, in fact. And if I'm restarting this, then it's like rebuilding it. It didn't rebuild the other schema. This one, it has fully pulled down again from what we have here as well. But if we, for example, if we would have deleted that thing while we're on Mars, then we're in trouble. This is like the source of truth, at least for a little while. And yeah, the beauty of it is basically that it allows you to change your database schema in any way you want. But as you're changing this, you also need to change those aspects, like how you interpret a mutation. So for example, if in here you're saying a to-do always has a color and a color is not nullable, but let's say we say schema.literal red, green, blah, blah, blah. Let's import this. In this scenario, this would not work anymore because if we replay this and we create some to-dos, they don't know, hey, what should I use for a color if that is non-nullable? So here we basically need to, now where we say the add to-do, here we need to provide like a fallback because otherwise we can't pull it out of nowhere. So we're saying red, and we can also optionally add a new color here, but that's really important that it's optional, because otherwise this data won't be valid anymore. Whereas like we're allowed to add an optional field here. That's okay, where the color, and you can here do a different syntax where you can pull out the data, but it's important that this is optional, since historically we haven't yet accounted for a color. So this is the only constraint that you need to apply, but the big kind of insight and assumption that's made here is, or really like an observation of having built many systems, is if you divide your data model into two parts, one is your read model and one is your write model. The read model is the thing that you constantly change your mind about. Like you change the way of like, how should the app look like? Do I want to have a list here? Do I want to have a board? Do I want to show this? This is all read model stuff. And for that, I can basically change my queries, where my queries. So this I can change at any moment. And if I say, oh, actually to do this properly, I would like to have my read model schema look a little bit different, then you can go ahead and do that. However, that the domain of your writes changes happens like orders of magnitudes more, like less often. And if you say, hey, at some point in 2025, we're introducing having colors for to-dos, that's totally fine. Then you can basically just like a product manager, whoever says, okay, as a default color, we're picking gray. And no one will be mad because they haven't like historically specified the wrong color. But people will be mad if you lose their data. And this basically preserves the entire history of intent of users, where you can always restore and recreate the read model. And I think and I hope I haven't explicitly read out the question. I will briefly do it, but I hope I've already answered that question. But Josh, do you maybe want to reframe your question and see whether that has already been answered?
Can you hear me now?
Yep, perfect.
You answered most of it. So that's all in the 030 version. Is that correct?
Oh, the 030, that will bring syncing, etc. But so far, LiveStore been mostly like local only, but you're already building up a mutation log, and that mutation log will then be able to sync.
So a couple questions. Is there like a flag or something you can add so it would delete the database if you wanted to just start fresh when you change the schema?
Yeah, so the database will be more or less implicitly the database file will still be there, but it won't be in your way. But I'd be happy to explore some options where you basically like never keep dangling old databases around. That shouldn't be a problem.
But right now, if I update my schema, it clears out all my data and starts fresh. In the new version, it won't do that. It'll migrate the data for me, which is cool. That's what I want. But what if you didn't want that and you wanted the data cleared out?
So if you want to start over from scratch without any traces, then you would do two things, depending on whether you are already using a sync backend. So the sync backend will always act as your fallback. So if a user, this is one of the key principles of local first software, is if a user destroys their computer accidentally, and they buy a new computer and log into or like off to something again, then a sync system pulls down everything just as before. That's one of the great benefits. If you don't want that, you also basically need to tell the sync, basically change the relationship to the sync backend. So maybe wipe the hard drive on the sync server.
Yeah.
What I like to do instead is introduce some sort of version number that specifies the database. So you notice that here in this folder structure, I've prefixed this with db5. I could basically pretend to say, hey, everything is gone by just changing that to db6. And it would also need to be incorporated on the sync backend as well. So this is a simple demonstration of this is if you change the store ID here to something new, now it's completely empty, completely fresh. There's nothing. So you could basically just by creating a new S3 bucket, etc. That is, in my opinion, since storage is so cheap, that is safer. Since sometimes you still want to go back and take a look at it during development. But there's also a flag in here where you can say hard reset, and that will delete everything here locally, but still pull it down from the sync backend.
And then a new question is, if I add a new field to the database, you said it has to be optional. Can you add a new field as default or with a default value in the schema, and then it would populate that default value?
That's a great question. So there's two things again. There is the read model and the write model. Let me just spell that out here. So there is the read model, and that is our SQLite database. And then there is the write model, and this is the mutation log. This is the mutation log. This is the write model. Hello. No. Okay. I wanted to paste in the mutation log here, but I hope you can connect the dots in your head. So this is the mutation log, and this is the data in the mutation log. If you use LiveStore just as is, you don't really need to deal with that. The way how you're exposed to the mutation log is to the write model is through your mutations. And then the read model, this is what you query. And the relationship between those is that everything that's happening in your read model is going through this indirection of those mutations. So you are free to change this as you want. You can like here create like another table and do here whatever you want, non-nullable, go crazy, doesn't matter. The only thing that matters is that you treat this read model appropriately from your mutations. So if you create a non-nullable thing, you're totally fine creating non-nullable things here in your read model. You only need to make sure that as those mutations get rerun, as you run through like a history of actions in Redux, you just need to make sure that, for example, as we introduce this required field over here, you need to make sure that you also respect that in the insert here. Where you now need to be a bit more careful is how you evolve the arguments of the mutations. So here, as you want to maybe from within your app, let's say here, I think in the header, we're saying add to do, that we in the future can also introduce like the color here. Now we want here the best of both worlds. We want to allow this in the future, but we also need to make it optional to account for the historic mutations. Another trade-off you can make is by versioning your mutations. So you can, for example, say add to do v2. And here you could also make it non-optional. And here you would basically need to use that v2 where you're now required to provide a color. So you still basically need to deal with both the old events and the new events. But those are like the various ways how you can deal with it. Like it's very like what I would recommend to get more familiar with this is just dig a little bit into like how event sourcing works. But those trade-offs are, in my experience, much more favorable to keep iterating on your app.
Cool.
So I hope that makes sense. Yeah, I think we're nearing the end. We had a little bit of a later start, but I still want to take a look at some of the other questions, and I think I can go through them a little bit more quickly. That person asked one question here about durable objects can get very costly. So in this particular issue, there's 2 points and both are not directly relevant for LiveStore. One is what made durable objects expensive is that they were not using a feature of durable objects called Hibernate, which LiveStore is using. And the other part is that LiveStore is treating the sync backend in like a more or less stateless way. So when the durable object comes online or when it gets called, the question is like how much work does it need to do? And is there like something that needs to be kept alive in memory or not? And with LiveStore, there's actually like very little work that needs to be done on that sync backend. All the sync backend really needs to do is keep this log of events, and a client will just ask it, hey, give me everything since 1. And then it does like a simple lookup of, okay, here's all the events since then, maybe sends it over in a couple of chunks to not overwhelm the network in between, and then it can go asleep again. That makes LiveStore really, really cheap to run on durable objects as one option. There will be other options. Then another question here was in regards to durable object scaling. I would question that assumption here. We can't have one durable object per user. That's the entire point of durable objects. And my suggestion would be to see whether your application can be built and architected in that way, where you basically want to design it in such a way that each meaningful thing, so for example, a Notion document, a teal draw canvas, a folder that you share with someone. Each of a thing should have its own durable object, should have its own mutation log, and you're going to have a lot of those instead of just having, traditionally you had one huge Postgres database, and in this approach you have many small things. And my suggestion would be to try to embrace that and see whether that's possible.
One correspondence there between a LiveStore database and a durable object.
So by default, there's some degrees of freedom, and I'm trying to, in the way how I'm building the LiveStore, like the LiveStore Cloudflare Worker durable objects sync backend, there will be many of those, but in this particular instance, I'm trying to employ mechanical empathy towards how durable objects want to be used to be as cheap and as efficient as possible. So in that regard, I'm trying to create a one-to-one mapping for one app ID or store ID that is currently mapped one-to-one to one event log, and from which you then derive a read model. But an app can have multiple of those. So just in this app, for example, you see here's all the different ones that I've opened it with. And in similar, this can give us a little take of like how it looks like in like a Cloudflare durable object data center. There's going to be just like a lot of those. And so that is like the building block that you can start with. And if you need more flexibility to, for example, do joins between those, that is like another interesting follow-up question where you could, for example, interpret multiple event logs into a single read model. That is something that's already possible. It's just not, I just haven't productized that yet with LiveStore yet. But I think you can already do. Any thoughts on OP SQLite? It supports vector search and apparently used by parsing. I've looked at it. My understanding is that it is specifically meant for React Native. I need SQLite support across all platforms. For React Native, I'm using the built-in SQLite by the Expo folks. On web, I'm using the WA SQLite. This doesn't provide anything in particular. I think in regards to fast is the main thing. What makes that fast is I think that it does synchronous calls, which LiveStore is also doing. What is interesting is the encryption and the vector search. With LiveStore, I'm planning to add support for SQLite Vec, which is a great SQLite extension that adds vector search support. So I'm planning to integrate that at some point, which allows you to build AI apps, for example, with like RAG and so on with LiveStore, which I think is really interesting. And encryption is a different thing that I'm investigating, but that's gonna be quite a lot of effort. And I think it's not necessarily the responsibility of LiveStore to support encryption out of the box, but encryption is something very domain specific that is related, that is strongly hinging on the trade-offs of a particular app. I want to help folks who want to implement end-to-end encryption, for example, but that is something that is like starting in application land and then supported by building blocks from LiveStore. And then last question here, permissions and relationships. I'm not sure about relationships, since in SQLite you can already do relationships as joins, etc. Permissions is not something that LiveStore currently does. And I'm similar to my previous point. I think this has to be, it's so specific to your domain logic that it's not something that I even plan to support out of the box with LiveStore, since there's a gazillion ways to do it. And it should be up to the application developer to choose the right fit there. And so it's a application concern for now. Cool. I think we're running at time. Maybe time for one more real-time question. I see a question here. How does sync work? Does it push the mutation logs into the backend or just upload mutation parameters to the backend and sync it manually to Postgres? How does it work? I think we've addressed this in the conversation before, and maybe you can take a look at the recording afterwards. But it takes a more principled approach where there is no no like traditional backend, but there's like a sync server. Cool. Are there any more questions? Thanks so much for joining in again. And yeah, probably gonna do another one of those in the coming months. So thank you so much for coming by.